Hello everyone. So here in this problem we have to evaluate limit x tends to 1, x plus x square plus x cube plus dot 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 plus x raised to n minus n whole upon x square minus 1. Now before starting this problem, let's understand the given term. So here in the limit we have algebraic function, and whenever we have algebraic function, that time we always start with direct method, and if we get 0 upon 0 in direct method, then we apply some other method. So before applying direct method, let us understand the term which is given in the numerator. So if you'll observe, then the last term of this series is x raised to n, and that same n comes here. So let's understand this concept. So let's say n is 4, so that time this will become x plus x square plus x cube plus x raised to 4 minus 4. It means the term which is in the numerator will change as the value of n will change. So when we'll assume n as 8, this will become x plus x square plus x cube plus so on till x raised to 8, and this will be minus 8. So let's see how we get answer for this term. So first of all, I will assume this given limit as L, which is limit x tends to 1, x plus x square plus x cube plus dot 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 x raised to n minus n upon x square minus 1. Now by direct method, we will get L as 1 plus 1 square plus 1 cube so on till 1 raised to n minus n upon 1 square minus 1. Now to evaluate this, we'll again come back to this concept. So when n is 4, here we assumed n as 4. So when n was 4, we were getting x plus x square plus x cube plus x raised to 4 minus 4. So when we'll substitute x as 1 in direct method, then we will get 1 plus 1 plus 1 plus 1, that is 4 minus 4. So that time we get 0. Now here if you'll see, instead of 4 we have n. So it means this 1 will be repeated n times. So n times 1 minus this n will also give us 0. Similarly 1 square minus 1 is 0. So here we are getting value as 0 upon 0, which we call as indeterminate form. So whenever we get indeterminate form, that time we say direct method fails. So here I'll say here direct method fails. Now to evaluate the limit, we have to use some other method. So let's start with it. So what I'll do is, I will rewrite the given limit as limit x tends to 1, x plus x square plus x cube plus so on till x raised to n minus n upon x square minus 1. Now in the denominator, we can apply the formula a square minus b square, and we can get a minus b, a plus b. Whereas in numerator, I will again consider this example. So if n is 4, then that time we are getting last term as x raised to 4 minus 4. So this minus 4 we can divide in these 4 terms as x minus 1, x square minus 1, x cube minus 1 and x raised to 4 minus 1. So I have given this minus 4 as minus 1, minus 1, minus 1, minus 1 to all these 4 terms. So if let's say n is 8, so that time we'll get last term at x raised to 8 minus 8. So that time we'll be having 8 ones. So those 8 ones we can divide in 8 different x. So by doing that we can distribute that one evenly in all the terms. So that funda I'll use over here. So by using that concept, here that n can be divided as x minus 1, x square minus 1, x cube minus 1, so on till x raised to n minus 1. So we'll get L as limit x tends to 1, x minus 1 plus x square minus 1 plus x cube minus 1 plus so on till x raised to n minus 1 upon, here we'll get x minus 1 and x plus 1. So it means here I am using the formula a square minus b square, which is a minus b and a plus b in the denominator. Now let's solve the numerator. So in the numerator we will get L equals to limit x tends to 1, x minus 1 as it is. I will write x square minus 1 as x minus 1 and x plus 1 by using this formula. Similarly, this x cube minus 1 will become x minus 1, x square plus x plus 1. So here we are using one more formula, that is, here I will write a cube minus b cube, which is a minus b in the first bracket, and a square plus ab plus b square in the second bracket. So by using this formula we are getting x minus 1, x square plus x plus 1 at this place. So similarly we can get factors for each and every term. So for x raised to 4 minus 1 we can get term like x minus 1 into x cube plus x square plus x plus 1 plus for x raised to 5 minus 1 we can again get x minus 1 into x raised to 4 plus dot 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 and so on plus dot dot dot, and in the last term we will get x minus 1, x raised to n minus 1 plus so on. So we got the formula for each and every term of numerator. Denominator is as it is. Now from numerator we can take x minus 1 common. So this will become limit x tends to 1, x minus 1 in the bracket, here we'll get 1, from here we'll get x plus 1, from here we'll get x square plus x plus 1, from here we'll get x cube plus x square plus x plus 1 and so on. Similarly from denominator terms are as it is. Now from numerator as well as from denominator we can cancel this x minus 1, and for the remaining terms we can apply direct method. So by direct method we will get 1 as it is plus 1 plus 1 2 plus 1 square plus 1 plus 1, that is 3, plus 1 cube plus 1 square plus 1 plus 1, that is 4, so on till n. And in the denominator we will get 1 plus 1 as 2. So here I am applying direct method. Now if you will observe the numerator, then in numerator we got arithmetic progression, and for this arithmetic progression we have the formula, that is 1 plus 2 plus 3 plus so on till n equal to n into n plus 1 upon 2. So I will apply this formula over here and we will get L as n into n plus 1 upon 2 whole divided by 2, so that this term will become n plus 1 upon 4, and this is the value of given limit. Thank you.